Random or probability sampling is a technique used to create samples that have the same characteristics as the population that they represent. The generalizability of a sample refers to the ability of its findings to be applied to a larger population. Representativeness, random sampling, and sample size all contribute to generalizability. In a simple random sample, any group of the population has the same chance of being selected as the sample as any other group. Each sample of the same size is just as likely to be selected. A simple random sample of employees at a company could be selected by assigning each of the employees a number, then using a random number generator to select 30 individuals from the entire population of employees. The pros of this technique is that it's straightforward and easy to execute, as there are no subgroups or categories. Selection of one individual is independent of another, and the results are often generalizable since selection bias is minimized. A con of simple random sampling is that it's expensive and time-consuming, as it involves compiling a list of all the individuals of a population. It can also be difficult in populations that are spread out versus more localized sampling techniques. Additionally, in some populations, purely random samples may not be sufficient to capture minority subgroups. A stratified sample is selected by dividing the population up into strata or groups, then randomly selecting a proportionate number of individuals from each strata. For example, to get a stratified sample from a school, you could divide that school up by classroom, and then select 4 students from each classroom. This is assuming that all the classrooms have the same size. If the classrooms are different size, then a proportion of each classroom, such as a fixed percentage like 10%, would be selected, making the number of students from each classroom vary based on the size of the classroom. Then larger classrooms would be represented more in the sample. Stratifying by certain characteristics or demographics, such as age, race and ethnicity, occupation, or gender, can ensure that the population is properly represented. This sampling technique is often cheaper and more time efficient than simple random sampling, since the population can be more accurately represented using a smaller sample. Additionally, comparisons across strata could give insight into differences between different subgroups within the population. Since this sampling technique can often be complex, it requires rigorous planning and background knowledge of the population's demographics. It can also be challenging to use in large populations, leading to complex data sets and specialized statistical software. Cluster sampling involves dividing the entire population into clusters or groups, then selecting all of the members from each randomly selected cluster. With stratified sampling, a certain number of individuals from every single strata are randomly selected, whereas an entire cluster is selected, leaving the others completely untouched with cluster sampling. Clusters are often naturally occurring groups, such as a specific geographical area, like a city block or a zip code. For example, to sample an entire city, each zip code within the city could be considered a cluster. Then 5 zip codes would be randomly selected from the entire city. Every single individual within these 5 zip codes would make up the sample of the city's population. Cluster samples can be very cost-effective and much faster to perform, especially in populations that are spread out, since sampling an entire cluster can greatly cut down on traveling. Furthermore, this technique is fairly straightforward and easy to implement, requiring less organization by eliminating the need to identify the individuals within any unselected clusters. Since individuals within each cluster will likely share more in common with each other than the individuals within a different cluster, there is unfortunately a much higher risk for sampling error, often minimizing generalizability. Systematic sampling often involves taking every nth individual of a population after randomly selecting a starting point. To systematically sample a company's employees, a list of employee phone numbers can be compiled into a directory in no particular order. A random number generator could then be used to select the first phone number to be included within the sample. After, every 6th phone number would be selected until the desired sample size has been reached. This technique is easy to execute, particularly when using population lists. It often produces a sample that accurately reflects the population while also eliminating the need to randomly select more than the first individual. Systematic sampling can save time and money, making it a less resource-intensive option. If for some reason the population list contains a hidden pattern that researchers are unaware of, systematic sampling can introduce periodic bias, making the sample unrepresentative of the population. Additionally, after the initial starting point, selection is no longer completely random, leading to lower generalizability.